this is example 2 off our KVL KCL. If you saw the previous video, we did the first example. Now what we're going to do is add an additional resistor here and show you the method really never changes, right? You just keep the same method. And so we get started. So step 1 is identify the loops. So this is loop 1 and this is loop 2, right? Just like we did in the previous video. Second is to identify the nodes. Again, this is node A. Okay? Now, again, we'll review why you don't do a second node here and why it cancels out, but we'll do that in a later video. Okay? So what we want to do now is draw the currents going in or out of the node. So we have our node A and we have our current going this way, right? We have a current going this way. Clearly it's going to come here, I1, I'll call this I1. So I1 is going into the node here. So what's going to happen? I2 is coming out of node A here, and I3 is going into node node A, node 3, not node A here, right? So we just drew this. And you can call these currents anything you want. You can say IA, IB, IC, I smiley face, I frowny face, I angry face, whatever. It makes no difference, okay? And then write out voltages. So when we write out the voltages, this is going to be VR1 here. We're going to be VR2 here. It's going to be VR3 here. And it's going to be VR4 here. Okay? Those are going to be our voltages. Because I1 travels across, it drops down. I2 travels down. It's going to create a VR2. I3 is going across. It's going to create a VR3. And guess what's coming down? I3 is coming down here again, dropping down VR4. Remember, I3 goes from here, here to here. Okay. Now we set the problem up. Let's set up our equations, right? Loop 1, loop 2, node A. So loop 1, KVL, second sign. Okay? And in this KVL, what we're going to write is sum of the volts going around the loop. So sum of the volts, right? Let me get my summation sign correct. Let me just erase all this. Let me probably make it a little cleaner for you guys here. You probably appreciate this more anyway. Here, right here, 0. So we'll adopt the second sign convention as you travel around. Second sign, second sign, second sign, just like that. You travel around the loop. Then we write down plus Vs minus VR1 minus VR2 is equal to 0. So Vs is what? 10. Minus VR1, I don't know. VR2, I do not know. Equals 0. When I don't have an I don't know, it becomes an IR. So 10 minus I1 R1. VR2 is I2 R2. Just like the diagram. So that's 10 minus I1 times 10 minus I2 times R2, which is 5, is equal to 0. Okay, so we have the equation that's, we had this previously, so I'll just write it down. 10 minus 10I1 minus 5I2 is equal to 0, and I'm going to do an algebraic shortcut. You should be able to handle this algebra, which is 10I1 minus plus 5I2 is equal to 10. Okay, so then what we want to do after this is we do loop 2. Okay, loop 2, again, it's KVL, and we take second sign. Okay. Okay, second sign, and we're going to travel clockwise around the loop, right? I can choose counterclockwise, it makes no difference, but I have to be consistent. So here, it's plus equals 0. That means as I travel, this is plus, so I'm going here. So this is my second sign here. I travel second sign here. and I go second sign here, right? And I count the tick marks. So plus VR2 minus VR3 minus VR4 is equal to 0. What is VR2? We don't know. VR3, we don't know. We don't know. So this is we don't know. We don't know. We don't know. If we don't know it, it becomes the equation IR, I2, R2 minus I3, R3 minus I3. So we have, I'm sorry, I2. If I have I2 here, right? I2, R2, I3, R3. If you can't see it, I3, R3, right? And then what we have, VR4 is going to be I3, R4. VR4 is here, I3, R4. Minus I3, R4 is equal to 0. Just like that. Now we kind of write out our equation. So my R2 value is what? 5. My R3 value here is 10. My R4 value is 5. So 5, 10, 5. So that's 5I2 minus 10I3 minus 5I3 is equal to 0. If I simplify it, I get I2 minus 15I3 is equal to 0. Node A, KCL. Okay, so now at node A, let's write our equations. So our equations at node A, right, we'll write out KCL. Sum of the currents is equal to 0. So is I1 coming in or out of node A? It's coming in, so that's plus I1. Is I2 coming in or out? It's coming out, so it's I2. Minus I2 is I3 going in or out? It's going out. It's minus I3 is equal to 0. So therefore I1 is equal to I2 plus I3. Okay, so now we have our three equations, three unknowns. Here's our first equation under loop 1. Second equation under loop 2. And our third equation under loop 3. Okay, this is the crux of the problem. Now, in the next videos, I'm going to show you exactly how to reduce this.